So this is your first bracket divided by n plus second bracket divided by n plus so on so forth plus last bracket divided by n. That is how it is going to look like. So this part is j1 plus j2 plus jk. So you understand why 1 by n comes in j1, j2, jk now?
Yes, sir.
It's just fractions, right? I am rearranging the terms in the fractions. That's why those 1 by n are coming in there. And the cardinality will come in the expression of zj, where you are finding out mean of a group. So that's why I'm saying you have to work out this by your hand on your own to make sure that everything that we have done so far is correct. Okay.
Yes, sir.
So yeah, so what happens in k-means algorithm? So now we have understood how this thing really works with respect to two different sets of decision variables. And it looks like in each case, when you fix one part of decision variable and try to find out the other part of decision variable, you seem to see that, okay, you can quickly optimize. So if I fix the cluster assignment, I can very easily find out what is the optimal value of the cluster representative. And if I fix the cluster representatives, then I can very easily find out what is the optimal cluster assignment, right? So it looks like an interesting way to understand the cost function, but based on this we can actually come up with an iterative algorithm, and that iterative algorithm is actually the k-means algorithm. Okay, so what is that iterative algorithm? Iterative algorithm is what you do. So I will just write down k-means algorithm. So given a list of n vectors, so what is the input? Input is data points x1, x2 up to xn, capital N, and initial k fixed. So we will fix the k and we'll take z1, z2 up to zk. Okay, they are also fixed. So I will fix the number of clusters and I'll fix the representatives. And then what do I do? I repeat this. What do I repeat? I repeat this thing. Partition the vectors. Partition x1 up to x capital N in k groups, k clusters. How do I do that? I do that using the discussion that we had on page 1. And then what do I do? Then I do this. I update the representatives. How do I do that? I do that by the discussion that was done on page 2. Deboje, can you please mute yourself? Thank you. So these are the two steps that I will repeat. And how long I will repeat these two steps? I will repeat these two steps until convergence is achieved. So what happened? I wanted to minimize this J cluster. I want to minimize this J cluster with respect to three different decision variables: the number of clusters, the cluster assignment, and the cluster representative. These are the three decision variables I want to work with, and optimizing with respect to those three decision variables all together is really going to be a difficult task. Okay, that is really going to be difficult. So what I do, I fixed K, and once I fixed K, even then simultaneously optimizing over cluster representatives and cluster assignment is still a difficult task. So I do it in a sequential manner. So what is the sequential manner? First I fix the cluster assignment. First I fix the cluster representatives. Once I fix the cluster representatives, I can assign the vectors or data to the cluster. Once that is done, then I can update the representatives, because now I know that in cluster 1 there are three data points. So in cluster 1, if there are three data points, then what happens? Those three data points, I'll find out the mean. That's the updated cluster representative, that is new Z1. Then I have 10 data points in cluster 2. I will find the mean of those 10 vectors. Then I will have Z2 and so on and so forth, right? Up to ZK, updated values. Again, I use those updated values of cluster representatives and I partition the given data set x1, x2 up to x capital N into K clusters. Once again, nearest neighbors. Once again, I update the representatives. Once again, I partition into clusters. Once again, I update the representatives and I keep on doing this process until the value of the J cluster is not changing significantly. Significantly, I will decide up to 1 decimal point, up to 2 decimal point. It's up to my convenience, my application demand. So that's what I will do. So this is the way the algorithm is going to work, and this algorithm is actually called as k-means clustering algorithm. So now is it clear what is happening in k-means clustering algorithm? So k-means clustering algorithm, first thing you have to understand, is not always going to give you the optimal clustering in the sense that we have no guarantee that by going through these steps, you will actually reach the true minimum of J cluster. We don't know. But as far as our application is solved, as far as the clusters that you get out of this algorithm are reasonably acceptable to you, you don't really worry about it. So that's suboptimal clustering that we were talking about yesterday. So now are the things clear? Is this clustering thing falling in perspective now? And is it clear how linear algebra is really coming into the picture? All these operations that you are doing here, they're all linear algebra operations, right? Norm, mean, everything that I'm talking about here, they are all the operations that you studied in your first 5 lectures, right? Coming out because of inner product, coming out because of linear combination, and so on and so forth. So this is nothing but all linear algebra that you are doing. In different name, right? So the names are different. You're calling cluster representative. Basically, it is mean of the vectors, right? So it's a linear combination of vectors that you're taking. So that's the reason why linear algebra plays a very crucial role. So this is the first application where very basic minimum linear algebra that we studied has straight away applications in one of the important algorithms. This is k-means clustering algorithm. So do you have any doubts about this now? What is the repetitive procedure? Do you understand?
Sir, could you please explain how the algorithm convergence? I mean, how do you prove that this the algorithm repetitive algorithm will converge?
Yeah, so there is a proof which I am not really going to take in this class because proof is little bit involved. Okay, so there are proofs why this algorithm will always converge to some value. Okay, so why? So one thing that is sure is that this J cluster value will decrease because of this algorithm. Okay, so that is sure. So how fast, how quickly it decreases, all these are the things which depend on initialization. You have to fix the value of k. So you change the value of k, everything is going to change. So there are lots of things that are there that needs to be looked at in order to show that this thing really is going to work. So J cluster value is going to decrease. So it's a difficult thing. It is not undoable. It's a difficult thing. People have done it. If interested, I'll provide with the references later where you can look up. But that's a nice question. That is important thing. You should know why the values decrease. For the time being, you can take it on faith value.
Sir, can we take a small numerical example? Say just a 5 points or 2 clusters.
Yes.
Sir, can you please just give a numerical example on this? Just 5 points and 2 cluster points.
So that you will do in your assignment problem. So all these things will come in your assignment. So this is hands-on. I cannot really do these things in the class, okay, because I have to calculate so many distances and all those things in the class. It is really very difficult, and this is something that is not difficult to code. So you can write two lines code for each step, and once you write that, you can see for yourself. So all these things will be nicely done in your first assignment. So you'll be asked to do all these things in first assignment. So it is best to do it on your own so that you understand all the small things that I have talked about.
Okay, sir.
Sir,
Yes.
at this point, can you tell how did you decide the values of cluster representative initially? Like randomly or just looking at the data?
So yeah, there are several ways in which you can do that. So you can at first see random assignment, or you can choose some vectors from the data itself. Given data x1, x2, xn, you can choose k vectors from that data itself. It's completely up to you. And the interesting part is that you change the initialization, then you will see that that initialization also has an effect on the results that you obtain. So all these things you will be actually doing in your first assignment. So we will ask you to change the initial condition from this to this, and then you will be required to see how it changes really, and so on and so forth. So that is something that you can see. So that thing you can play around with. But initially how those are fixed, it's up to you. So it's a numerical algorithm in mathematical terms. So how is initial condition chosen? It's up to the user. So if you are well informed a priori that what are the clusters, and if you know your data really very well, to know that what are the probable choices of Z1, Z2, Zk, then you can assign those choices of Z1, Z2, Zk, and your algorithm will converge very quickly. On the other hand, if you have absolutely no idea about the data, you have no clue what the data really is, then okay, what you can assign them randomly, or you can assign some k vectors in the given data as the initial choices for the clusters, and so on and so forth. You can do that. That's fine.
Yes, sir, got it.
Atif, you want to say something?
Yes, sir. So just wanted to ask, the optimal clustering will always occur when k is equal to n.
No, so k is equal to n, that clustering is not a very useful clustering, no? So
Yes,
we'll
sir.
always consider k less than n. If you have k is equal to n, then you are saying there are as many clusters as data points, does not make sense, right?
Yes, sir. That is
From the application point of view. So you never consider that case.
so. Sir, we always consider the suboptimal clustering.
No. So for a given value of k, what is the optimal clustering is the question basically we are asking.
Okay. Okay. Understood, sir. Understood.
And
Sir,
that k also you have to change, like you have to change 3 clusters, 4 clusters, 5 clusters to see how the j cluster value really changes. So it will change, and after doing it several times, so you can take 3 clusters, 4 clusters, 5 clusters, then after 5 clusters, so the value of the j cluster is decreasing when you increase the number of clusters. But after one particular cluster, say cluster number 5, so you have 5 clusters, then you increase the number of clusters, this value of j cluster does not decrease significantly. That means that you have sort of hit the saturation. So that is also one test to decide how to choose number of clusters. So all these things you have to experience. So through the data sets that will give you, you can experience. That's fine.
understood, sir. And so one last question.
Yes.
If, sir, because there's a cost function involved and we're minimizing that cost function, is
Yeah.
it also possible to use gradient descent to get our means?
Yeah, you can do that.
Okay.
But gradient descent and all, if you use, what are the solutions that you are going to get
Sir,
for the
based
mean?
so based on gradient descent, we can find the cluster representatives by updating according to that.
Yeah, but you have to update the assignment also, right? So you
Yes.
cannot. So these two steps you have to take anyway. And I don't understand exactly what you mean, but oh, sorry. So these two steps you have to take anyway, and when you take these two steps, how to find ZJ is really straightforward, right?
Yes,
Why
sir.
do you need gradient descent for that? I don't understand. Like, you are actually getting the optimal value for Zj directly. You don't even need gradient descent. So gradient descent is a method in which you will apply a numerical algorithm to approximately find out value of Zj. But here you are getting it exactly, no? So
Yes, sir.
I
Yes, sir.
don't,
No point.
is that clear what I said?
Yes, sir. Understood,
Does
sir.
that answer? Yeah, okay, fine.
Oh, thank you, sir.
Yeah. Any other doubt? Any other comment? So is this algorithm sort of clear, the k-means algorithm and what it is really doing? So let me see if I have got any message from. Yes,
Sir,
yes.
actually I was out of connection for a while. So did we discuss how do we fix the K?
Yeah, just now I discussed a minute ago. So what you really do is the following. You fix one case. So for example, 2 clusters or 3 clusters. Then you apply this k-means clustering algorithm and find out the clustering, right? So you solve. So for k is equal to 2, you apply this algorithm. You find out some clustering. That is done. Then there is some value j cluster associated with this particular cluster numbers 2. Then you do it for clusters 3. If you do it for clusters 3, then probably the value of j cluster will come down. If you do it for cluster 4, the value of j cluster will come down further. So once this value of j cluster stops coming down significantly, at that point you can stop. So if you see that at cluster 4, so if k is equal to 4, then for that k is equal to 4, you had some jump from 3 to 4 in j cluster value. 4 to 5, there is no significant jump. The value in j cluster does not change as much as you would have seen in the previous jumps. Then you stop at k equal to 4 and then you declare k equal to 4 is the number of clusters in the data.
Yes. Yes.
That is one thing. And the other thing is that you decide a priori that, okay, I know that this data has 10 clusters. That's it. So I will work with 10 clusters only. Does that answer your question?
Yes, sir, indeed.
Okay. Okay, so I just saw Sumanta has sent an email with the YouTube link, but now it's almost 10:20. So we will not be able to see that video right now about the MNIST digits and the digit data and what really happens in digit data. So I will just try to explain quickly in 2 minutes, 3 minutes what that data really is. Most of you might know. So the data is collected where different people are asked to write down the digits by hand. So you write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. You write by hand and you submit that, right? So say some 60,000 people roughly were asked to write down the digits. So now as you can see, different people have different styles of writing. So somebody might write one in a different way. Somebody will just put a straight line. Somebody will put a one like this, somebody will put a one with a horizontal line down, and so on and so forth. So there are different ways in which you can write down one. Even the 0, the shape changes with respect to person. 7, 9, there are lots of things where a computer might get it wrong. So what is the objective? Obviously the objective obviously is that these are the digits that are given to you. I will not tell you which one is the which digit. So human brain is amazing, so you can look at it and you can tell whether it is 0, 1, 2, 3 or not, but a computer cannot tell. So a computer needs to learn to distinguish between these digits. So in this particular example, obviously k is equal to 10 is the cluster number you have, right? So all the zeros will go in one cluster, all the ones will go in same cluster, all the twos will go in same cluster. So that's how you have to do the clustering. So obviously you know that k is equal to 10 is the best choice for clusters, but you can say k is equal to 20 for different 20 clusters for different. So one written in this way also will get distinguished. So for example, if somebody writes one in this way and somebody writes one in this way, so both of them are one, but this one, all the ones written in this can get clustered into one group. All the ones written like this will get clustered into a different group. So based on that, you can decide, like even 7, many people have habit of writing 7 in different styles. So somebody writes 7s like this, somebody will write like this. So somebody writes 4 like this, 4 like this. All these different scenarios are possible. So no restriction was put. They were just asked to write down the digits. Then it was taken as an image. So this is an image. So image data that was 28 pixel by 28 pixel image data. So there are 28 pixels and 28 pixels. So 28 into 28, those many number of pixels are present in the data. So what is pixel? So you will divide it. So there are 28 horizontal lines, 28 vertical lines. And what is the value? What is the value in this pixel? So the value lies between some numbers. So this is a grayscale image. So intensity is the value in the pixel. So that's how you read the image. So you convert this image into a vector using the vector operation that we discussed in the first class, how to view image as a vector. And once you have that image as a vector, then using Euclidean norm as similarity, using k-means algorithm with k equal to say 10, 20, 15, 35, whatever number of clusters you want based on how different ways digits are written, you can actually come up with clusters and you can see if there are any misclassifications, like this type of one getting misclassified as 7, for example. So this type of one getting misclassified as this type of 7. There is a chance, we don't know the way people write. If somebody writes 7s very clumsily like this, computer algorithm may confuse it for one written in this particular way. A human eye will tell, no, this is 7, this is 7. But a computer might think it's 1. So there might be misclassifications. So what is really happening? How to do these things? So that's the first problem. That's one of the problems in your first assignment. So how to handle this MNIST data? I probably hope he has also told. Sumanta has also told how to download it and so on and so forth. Where is it available? So all these things probably are explained in that video link, which I will share with you. Okay, so that's the video link I'll share with you. I see that the recording is still going on for this, so I will see if I can edit the video, remove the part where we miss the connection and so on and so forth, or I'll try to sort of do a quick 25-30 minute video, record it and upload it instead of this long video, which is like too long. So that's what I'll try to do. So please see the YouTube link I will send, that is made by Sumanta, and he has explained how to read the values in the pixels, how to convert that image into a vector. And once you have a vector, then you have to do the things on your own further, like apply k-means algorithm and so on and so forth. So what you are supposed to do, we will write a problem nicely and we will tell you. But before we start giving you problem on Monday, on the weekend, if you can play with this, I will share the link after the class right away. If you play with that, it will be better. Okay, so that's what I wanted to say.
Sir, I have just one question. Here we are using Euclidean norm to kind of find out the value of the ZJ, right? We are finding the differentiation, and that's how we get the ZJ as the mean, right? But what if we take some other similarity function? How do we optimize that?
So you have to optimize. You have to actually take derivative and find out.
Okay, so like, okay, fine.
So you have to solve that optimization problem actually. And now when you do that, maybe what Atif was saying sometime back might come into picture. If you're not able to solve that optimization problem easily, as we were able to solve in order to find out ZJ, then you have to apply some numerical scheme. The one that Atif was mentioning was gradient descent algorithm, where you will approximately find out what is the value of ZJ. But I don't think it will come to that. Or because this is a approximation algorithm anyway, you are not getting exact value anyway. So what you can do is you can approximate the representatives in whatever similarity, whatever definition. It's not a good thing to do, but you'll say that I'll always look at the mean. That's not the best thing to do, but you can still say that whatever similarity I take, I will still consider mean as the group representative. It sort of defeats the purpose, but you can still do that. So there are various ways in which you can handle such situations.
Okay, sir.
Is that okay, all of you? So now what I want you to do is quickly, all of you log into your Moodle accounts, okay? So please log into your Moodle accounts.
So just one point before going there, yesterday's slides are not available in Moodle.
Slides are not okay. I will write down. There is some problem with my iPad. I'm not able to upload it in Google Drive. So I will do that. I will send. Don't worry.